Hi, Jen here again, and I just wanted to give you a quick little update. This year, 2023, the first day of June, it has been so warm, and parts of our watershed in the lower St. Croix watershed received 0 inches of rain in the month of May. It's very, very dry, and I wanted to see what are the soil temperatures doing with the soils really dry, because soils dry up and cool off much faster when they are dry. And also we have the heat, we have the strong sun out. And does residue really make a difference on keeping our soils cool and thus reducing the evaporation and increasing the amount of moisture that we retain in our soils? Let's find out. A really easy way to check it is just using a thermometer. I use meat thermometers. I don't put them back in my kitchen when I'm done. I keep them in my vehicle. You can use digital. You can use the old school dial gauges. Either one, they work really, really nicely. They're not expensive, and it's a really neat way to just kind of go out and add that to one of your field checks to see the temperatures, because the soil organisms, they're similar to our preferences. We don't want it too cold. We don't want it too hot. We start getting 90 degrees and higher. The soil organisms, they really slow down. It's too hot for them. We get above 100 degrees, they really, really, really slow down. 120 degrees around there, they're done. They shut off. Also in the springtime, as it's cold, it takes a little while for them to warm up and get moving, just like us coming out of winter. So if it's a comfortable temperature for you outside, it's comfortable for your organisms in the soil. All right, on this little bare patch of soil, the air temperature is 91.2 degrees, and 2 inches down into the soil, where we have bare soils, we're at about 82.7 degrees. The seed trench on our no-till field, we were sitting about 75.6 degrees Fahrenheit, 2 inches down into the soil. Here's the strip till field. We're checking between the rows, 2 inches down, and it's 73 degrees. This is within the rows of the strip till field, 2 inches down, and we are getting 83.6 degrees. In the vertical till field, within rows, 76.1 degrees. Between the rows in the vertical till field, 71.6 degrees. The vertical till field that had cover crop, within the row, 72.7 degrees. So the soil temperature readings followed suit with the amount of disturbance and the amount of soil exposed. And so looking at the data, our air temperature at 91.2 degrees, our highest soil temperatures, that's where we had the strip till within rows and our bare soils. And with the amount of residue left over in those areas, that cooled the soil less than 10 degrees, 2 inches down. As we go down and have less disturbance, more residue, we're finding more and more cooling effect from that residue all the way down to the vertical till between the rows, 71.6 degrees. So it's cooling the soil by about 20 degrees. The no-till, it is a sandier soil than the others. And this is our third year of drought, so there's not as much residue out on that field as you normally would have. So that one is an outlier, but we can see, with the reduction of disturbance, the increase of residue covering the soil, we are getting a nice buffering effect. I took advantage of the shade for a minute. So very interesting findings on the effect of surface residue on the soil temperature. We took those readings 2 inches down from the soil surface, and that's directly impacting how much water we're evaporating and the crop stress that's happening. Again, as you heat up that soil surface, we are losing moisture, we're radiating even more heat, and taking that moisture away from our growing crops, which is really critical right now. So with those elevated temperatures, we are losing more moisture every day as the day goes on, as we increase these daytime highs. And while we're also having really warm nighttime lows, so we are seeing some crop stress in the area. We're hoping to get some more rain, and it looks like the fields where we had a little bit more residue out there, we're holding in more moisture, we're keeping the soil temperatures cooler, and we're creating less crop stress. So keeping residue on the soil surface is one of the soil health principles. Keeping it covered. You can keep it covered with living plants, dead plants, the residue from previous year's crop, cover crops. And then also what that does is it protects the soil surface from raindrop impact. It reduces the highs and lows of temperatures. And it protects the surface of the soil so that we can build the soil structure on the surface. And then when the rain does come, that water, the energy will be taken out of each of those raindrops when it hits, because it'll hit that residue, and it'll allow for that water to infiltrate and get down into the soil, into the subsoil where we need it, because generally it just dries up as the season goes. So we want to keep that soil covered, let that water infiltrate, and put that blanket on top to reduce extreme temperatures and reduce the evaporation of moisture. And it's really nice to be able to see all of that crop residue, the cover crop residue, providing that shade for the soils and the soil organisms to keep those crops less stressed, and reduce the evaporation of the moisture from the soil. And if you're interested in learning about different ways to increase the soil cover, the residue on your fields, stop by your local Soil and Water NRCS office, give us a call. We have programs and technical expertise to help determine ways that it can work on your farm.